Welcome back to Space Reviewed. I'm Andy. For this review, I'm going to look at Skynet 1A, the UK's first military communications satellite, launched 50 years ago. Skynet 1A provided an unprecedented amount of long-range communications capacity, helping our armed forces maintain a global reach. A lot of its bandwidth was actually used by GCHQ to move signals intelligence data around the world. To help the satellite do all of this, it was launched to a very special orbit. Here's the Earth and its atmosphere. Let's zoom out a bit. In the review of Ariel 1, I talked about LEO. Well, that's just the first of the altitude bands. After LEO comes MEO, medium Earth orbit, between the top of LEO and 35786 kilometers altitude. A bit of an odd number, but I'll get to why that is in just a moment. 35786 kilometers is geosynchronous Earth orbit, GEO, and beyond it lies high Earth orbit, or HEO. You might be thinking that we've zoomed out enough to see the Moon, and I've left it off this diagram. But the Moon is actually a lot further away. On the same scale, the Moon would be about 20 times the width of this video away. Space is big. Skynet 1A was launched to GEO. It's a lot closer than the Moon, but GEO is still a very long way away. To make it a bit easier to get there, it wasn't launched directly to GEO. First, it launched to LEO, and then it went through a transfer orbit to get all the way out. Now I promised to tell you why GEO was such a specific altitude. The time it takes to complete a single orbit is connected to altitude, and at GEO, an orbit takes the same time that it takes the Earth to spin once on its axis, a day. That means a satellite in GEO looks like it's effectively hovering over a single longitude on Earth. If its orbit is directly over the equator rather than inclined to the equatorial plane, it looks completely still in the sky. A special case called geostationary. GEO is great for a communications satellite because you can serve a fixed region continuously. It's also great for users on Earth because it means their satellite dishes can be fixed to point in a single direction. In contrast, if you want your antenna to point at a satellite in LEO, you need some sort of fancy motorized mounting and some clever electronics to track the satellite. You can also only see the satellite for a short amount of time before it disappears over the horizon, no more than about 15 minutes. So Skynet 1A made it all the way out to GEO and got on with providing communications links. Great. No nuclear bombs to deal with? No. Perfect. But then there was this. This is a special kind of radio signal amplifier. Because GEO is so far away, the radio signal needs to be powerful to reach us. After less than a year in operation, the amplifier in Skynet 1A failed, making it essentially useless. No matter, we had another one ready to go. Skynet 1B was launched in 1970. Unfortunately, it just wasn't to be. This time, the rocket getting it out to GEO failed, and it was left stuck in its transfer orbit. To sum up this review of Skynet 1A then, it provided global connectivity, which was great. It followed hot on the heels of Ariel 1 as another plucky British failure, and perhaps most significantly, it was 25 years ahead of the Skynet of the Terminator films, and nowhere near as malevolent. It was, however, still a failure. I give Skynet 1A 3.5 stars out of 5.